to the entire document body, and that will then be what you see on the screen. So what is main view?
Hold
That's
on.
something we have to go build.
Robert, are you okay
Yeah.
with people asking questions in the middle?
Or we can wait till
Sure.
the end too.
Yeah, that's fine.
All right, so I guess we have a question.
Yeah. So does the depends file determines what resources get loaded? Does Enyo.js just go looking for the depends.js in whatever the current directory is for that HTML file? So if you have, say, multiple windows, like no window app having like a root window and a second window, you would put them in different directories, they end up with different depends, or how does that work?
No, you have one depends file per app, and as you mentioned, it would go in the root of your application. And then if you want to have a more organized hierarchy of folders, so window 1, window 2, window 3, your resources, etc., you can do that. And then in your depends file, you just need to make sure you have the relevant paths to those files properly. So directory name, /file name, etc.
So every HTML file is going to end up with everything in depends getting run and executed.
Yes.
Okay. Thanks.
Okay, so let's create a quick main view.js. So I'm going to define an Enyo kind. That is Enyo.kind. And then everything inside is going to look like JSON. That's a curly bracket. I'm going to give this thing a name. And the name is my apps.mainView. So that way it can be programmatically referenced by other JavaScript files, other code in my application. It itself can be derived from a kind. And in this case, I'm going to just make it an Enyo.control. And one or more components, which think of these as like child controls. And to make life simple for starters, let's put a button. And I can say Enyo.button as well. The shorthand is without the Enyo namespaces will work. I can have a caption like button 1. And I can give it a name as well. Sorry. And this is like analogous to a DOM name, so that I can programmatically reference this button from JavaScript. And then I can have one or more DOM events that I can on, for example, on click, which, as you might guess, is when you click the button or on an actual device. This corresponds to tapping on the button. On the button one click. And that's it. And I'm going to just implement my function. Okay. Then on button one click. Function, and just for now, so I can show off some debugging tips, I'll just do console log button 1, like that. Okay, and then we'll save this as main view.js. So we have our Enyo.kind, it's got a name, these are derived, if you will, from control, and he's got the components. So now to run this, I can load this up inside of Chrome. Since everything's WebKit based, I should be able to drag this file. Oops, I have an error, so I'm going to have some kind of typo here, which I think is a capitalization error. Lowercase e starting. There we go. And there's my very basic application with a single button. Now, obviously, this is nothing that is going to sell, or anybody's going to really be interested in downloading. But what we've got, nonetheless, is a fully functional, architecturally complete and valid Enyo application. So anything else from this point on, basically, is going to follow some of the same principles. I mean, you've got the basic same structure. You may have more JavaScript files. You may have CSS files, etc. But every application from a structural point of view is exactly the same. So with that, I'd like to thank you. No, just kidding. So let's take a look at some quick debugging tricks. So again, since we're, everything is based on WebKit, we can use, in my case, I'm on Windows, so I'm using Chrome as my browser. I can use Chrome Inspector, and I can right-click or Control-I to pull up Inspector. Say Inspect Element, and I don't know if any of you have seen this before. If so, bear with me. If not, this is pretty handy stuff. For example, I can go into the Console tab, and since I put a console.log call when I click the button, when I click on button 1 here, I'm going to see button 1 clicked. So I can do some quick, console.log debugging. Another thing that's really, really nice is the scripts tag. You'll see dependent files loaded, and there's my main view. So I can actually now, view the JavaScript, the same JavaScript that we just wrote in Notepad++, but I can do things like set breakpoints. So I go here, I right-click on the line number, and then if I click this button, the debugger stops on that line of code. I can single step, I can continue, I can remove breakpoint by clicking it again, hit the little arrow here, and that will continue, etc. So I have a pretty, fairly rich debugging environment that I can use just from within the context of my desktop browser, which is really nice. So, getting, the 80% or 90% of the way to the goal line with your application, in most cases, you can do a lot of that within Chrome. Now, of course, if you're doing UK stuff and native, there's different tools for this we'll get into in a little bit. But for the majority of sort of your standard web-based applications for webOS, you can do a lot of this work in Chrome.
As someone that's built an app like this, I would say this is like the #1 feature for me of the framework is that you can develop in Chrome.
Yeah.
Like the component structure, all those other things are very nice to have, but
yeah, this is really, really handy for like when you're quick, you want to quickly try something out. You can do some of these same things in the emulator. I'll show you in a second, but the script debugging here is not one of them, so it is pretty handy. Let's say we want to add, obviously you can add more buttons. So let's do just a quick cut and paste here. Button 2 for everything here. What I'll show you is, we're going to move up to here is using Flex. Flex, not the Adobe tool, Flex the properties like CSS3 Flex boxes and such. On 1 click, search bar will do a handler for this. Okay. For this guy, we're going to make sure it works first in Chrome. So reload that. So there's 2 buttons. Now, just to kind of show you, we'll run this in the emulator. So once I've installed the SDK, I'm going to get a program group in here called HP webOS SDK, and then the emulator. So it'll take a few seconds to start up. I'm going to go boot my Linux VM in VirtualBox. So let's let this kind of grind away in the background while we play around with our app. So you see now we've got 2 buttons stacked on each other. What if I want to, make them horizontal, for example? I don't want them to be all vertically stacked. I can do things like this. Inside my component, in my main view, I can add something called, make it horizontal, so H flexbox. And this is basically, this resolves into basically CSS3 flexbox styling. And this flexbox doesn't have its own set of components, which we're going to make all of the buttons that we just built. So all I got to do is put them inside of that bracket, and you can close that coming out. So now, what should happen is my layout should change. And along the old step. So now they're horizontal. But they're just kind of all crammed over to the left, right? So now we have our emulator. Let's try this in the emulator first, and then we'll fix the layout. So to run this in the emulator, I'm going to use a SDK command. Again, I'm in LAMP. You see I've got my old 0.1 version of the framework. I've got the 1.0 version of the framework. And then I just have to go change that one script include line to make all my applications work in any version. What I do to make this run is there's a SDK command called palm run. And then I just have to specify the name of the directory that contains my application. And what palm run does is it does 3 separate calls. It does palm package, which basically generates the IPK file for your app. And an IPK file is the packaging format for applications for distribution through the HP app catalog. It then does a palm install, which takes that IPK and installs it on the target. And then it does a palm launch, which runs the application. So all 3 of those things can be combined up into one call here with palm run. The other thing that's nice then is that once the application launches, as you see here in my console window, is I'm still in this command shell. So when I go to the emulator and look at my buttons now, same application now automatically scaled for me to my screen size because Enyo is good about that. If I go click on one of the buttons and then go back to my command shell, you see the same console.log stuff happening down there at the bottom. So what you use Chrome Inspector to view in Chrome happens in the palm run shell when you're running an emulation. So that's kind of handy too. So some of the same debugging stuff you can do in the emulation. To kill this, I can just Control-C, and then back in the emulator, the application's closed. So let's go fix, before we move on to something more interesting, let's go fix the layout of our buttons, because they were all kind of crammed over to the side, which isn't terribly exciting. To fix that, what I'm going to use is an attribute called flex. And for this, I'm going to specify a value of 1 for both of these buttons. And we'll run this in the emulator again and see what happens. Go. Back to the emulator. Now they are horizontal as we wanted, and they are proportionally spaced horizontally across the screen. So that's what the flex property did for us if we're in a flexbox control, or if our main view is itself based on a flexbox. So what does flex mean? It's not like the percent width like you might be used to with HTML. What it says more is how equally spaced or how equally distributed are the components. So values of 1 for both buttons means each button takes up the same amount of space in the horizontal layout. So i.e. in this case, since there's 2 buttons, each one takes up half the screen. If I went back and changed the flex value for, let's say, the first button 3, and left the second button with a flex of 1, and there's still only 2 buttons, what this is going to say is these 2 buttons need to share the horizontal distribution themselves. And the first button has 3 times as much space as the first. So what should happen is the first button should be 3/4 of the width of the screen, and the second button should be 1/4. So let's run it again. Go back to the emulator again. That was right. Oops, sorry. So now button 1 is 3 times the size, 3 times the space as button 2. So again, pretty contrived example, but with more complex application, you can use flex, both vertical flexing and horizontal flexing, to get the layout that you desire for a more rich UI style application. So let's close that hello world. Go back to the slideware for a second. So we've built, deployed, and debugged to some degree our first